Yes, and what do we call that in everyday language? A box. That's just a fancy word for a box, so like my Kleenex box. This is a rectangular prism. What makes it rectangular? What makes this a prism? No, anything can be 3D. You're either a prism or you are a? Pyramids and prisms are the 3D shapes. What's the difference between a pyramid and a prism? Pyramid has a point, and that means it has one base. So typically it sits on the base and comes up to a point. Pyramids are one base figures. What's this? Two bases. So it has two parallel bases. That's the difference between pyramids and prisms. So if you look at a cone, for example, is that a pyramid or a prism? Pyramid, because it has the circle and then comes to a point. If you look at a cylinder, cylinder is a prism. That's all from grade 10. I'm sure you remember it. So if you need to put in brackets box, that's what that's telling you mathematically. It's a box. What else would you like to highlight? Already ahead of you. Start with the formula. You actually did all the volume formulas back in grade 10, unit 1.
All grade 10 should be heading down to the gym right now. That's grade 10 to the gymnasium.
Should.
Followed by the grade 11. Grade 11 should also be going on to the gym floor area. Teachers, please sit with your students. Thank you.
Formula for volume of a box or a rectangular prism. Okay, so you're expected to know a simple one like that. If they're going to ask a cylinder, they'll give it to you, or something that's really bizarre. But you are expected to know common shape formulas. Do we have a number for volume? Okay. Do we have a value or an expression for the length? Do we have a value or an expression or a number for the height? Do we have an expression or a number for the, what did we miss, width? You could. It's just they've given it as x in the question. That's why we're choosing to use x. What do we need to do? We need to solve it, just like we did with quadratics. These would be calculator questions, because obviously with 2100, they're not going to expect you to factor. We have now done trig equations graphically, radical equations graphically, and rational equation graphically. All we're adding today is polynomial equations graphically. There are two methods. What are the two methods? And please don't say method 1 and method 2. Intercept method and intersect method. One is where you put y1, y2. The other one, you put it all into y1. Which one would you like to use? Kate? What would you like to put into y1?
2100. Those teachers with students in grade 12, you can start heading down to the gymnasium, and we'll see if you're going to be sitting upstairs or on the main floor at that time. Thank you.
Now what? Y6. Yeah, we start with standard. It's probably not going to be a great number for this one, because take a look at the value of the volume. 2100. We have told the volume to go up to 10. So clearly, we got to change our window values here. Remember, x is the dimension, y is the volume. So do we need a negative dimension? So what can our x min be? 0, because we can't go past that. Okay, 3 dimensions are eventually going to give us 2100, so probably bigger than 10, because 10 times 10 times 10 is 1,000. So got to go bigger than 10. Give me a number. That would be really, really big. Really big. 25. Okay, let's go down to y, which is volume. Do we need a negative volume? And the max needs to be at least 2100. So let's go bigger. Do we what? 25. Well, because we have to go at least to 2100, right? because that's our volume here, so we want to show more than that. Okay, now what? How do we get marks for this question? Okay. So far I would have gotten 1 mark for the equation. I would have 1 mark for the graph. There's 2 more marks I need to get. Yep, point whatever, or mark, or put an arrow. There's point number 3. Do it, yes.
Second function trace.
And then we're picking. And then. Whew. Which of these am I looking for? What does the y tell you? It's just the volume. Not a big deal for this one. So we know that x equals 7. Are we done? Is that what the question asked? Said find x? No, what did it ask for? It says the dimensions. So which of the dimensions is x? The width. How are we going to find the length? Okay, so they've told us it's x plus 8. We just solved x, which is 7. So the length is? How are we going to find the, which one's left? Height. Okay, where does that come from? Offer of 20. And then we need some kind of units and some kind of conclusion sentence. So the dimensions are? Seven units by 15 units by 20 units. Welcome to Max Min Problems in grade 12. Questions so far? That's probably the easiest kind of dimension problems we're going to get. We're going to do 2 more just to show you how they're going to change it up. But first, let's painfully do a method together. What was the first thing we did here? So what could we call step 1 in? Okay. So create an equation. Period, or do you want to add more to that? Is it always going to be volume, though? It's going to be a lot of volumes because volumes make cubics. That's why last year you did area, because area makes quadratics. But not always cubics. No, area was last year. They typically won't give a lot of area. For the question. I probably would have said with the given information. Okay, what was our second step in here? Before that, so we wrote our equation, then what did we do? We graphed it. Again, you could have chosen to use the other method where you put it all onto one side and then solve for the x-intercepts. Would have given you the same answer. Okay, what did we do for step 3? So after we graphed, then we solved it. Okay, so step 1, step 2, step 3. Where did all this last stuff come from? Substitute. But is it always going to be a substitution? So I always like to put answer the question. So go back and look what the question is asking. Maybe the question just asked for S and we're done. Don't forget units, right? Because it's a word problem. Okay, read to read number 2, and then you can read to understand and highlight whatever you want to, and then I'm going to ask you what's the difference between 1 and 2. Let's give you a couple of minutes, read to understand, figure out what's the difference between 1 and 2. What would you like me to highlight? Thank you. Okay, what's the difference between 1 and 2? That's the difference. Here they told us the volume was 2100 and we were finding the dimensions. Here we're not finding the dimensions, we're finding the max volume. So let's look how to do it when they're asking you a max min. Steps are going to be the same. Step 1 is still create an equation. We need an equation for volume. It's still a box, so it's still length, width, height. Now, science people care which is length and which is height. Mathematicians, we don't. We say if you take this box and I tip it over, is that going to change the volume? What if it even fell into the floor? Does that change the volume? So we don't get caught up in too much as which exactly one is length, thank Mika, and which one is height. We really don't care. Pick a value, put it in for L. So what's one of the dimensions they gave you? I picked X because I heard that first. And then? Okay, so don't get too caught up in, well, which exact one is the height and length? To a mathematician, we don't care. Whether I tip this or I don't, it's still the same volume either way, assuming it has a lid and the contents don't spill out. Okay, the only thing that's different from last one is we didn't have a number here. Okay, we're still going to carry on. Will they always do what? Yes. Unless they use really easy numbers, but it's hard to get a volume that's that tiny. Okay, so what are we putting into X or to Y1? What do we go down and put into Y2? Well, we don't have anything, so we're just going to leave it. We're not going to put anything in. So we could zoom standard, then change the window, or we could try to see if the last window was okay, and that's just by hitting graph. It'll keep your last one. Okay, it's a little hard to see what's going on with this little bump here, so let's change our Y. Okay, so our X seemed okay. Let's go to our Y max, make it a little bit smaller. Offer 20. Okay, what did 20 tell us? Yeah, we can't see the peak, so I'm glad you said that because that shows you, okay, that was way too low. 400 was the second offer. Okay, hit graph. Ah, that's better, we can see it. Well, we know it's a cubic, right, so it's got to have that kind of snake feel to it. Okay, so let's sketch it, step number 2, just like last time. Whoosh. Ooh, I missed the Y axis there. Whoosh. Well, what are we trying to find if we don't have another equation that we can't do intersect? Well, what did the question ask for? Where's the max of this graph? Right on the top. Okay, so what's different from the last one is we were finding the intersect of the two. This one we're just finding a max. Well, you've done this a bazillion times with quadratics last year. How do we find a max or a min, if the question wanted? Second calc. Yeah, it's right on the list there. So maximum is number 4. And this is a left-right bound 1, so we have to go to the left of the max. Okay, so anywhere on the left of it. Hit enter, then it wants a point on the right. Hit enter, it's got the little arrow showing, hey, is this what you want me to find? And we get this answer. Well, you need to just be careful which coordinate you're looking for. So what does the x represent? What does the y represent? Well, what are we trying to find? Volume. The x is just this dimension. Did it want the dimensions? So although we know the value of x, it's irrelevant to the question. What do we want for this one? The y value, because that's the volume. So what is the maximum volume? Were there rounding instructions in the question? Do we have units? There you go. There's a max-min question. That would probably be 3, 1 for getting the equation, 1 for getting the graph, 1 for getting the answer. Is always the y value. Same thing with quadratics last year. The max-min is the y value. Again, the x is fine. It tells us the dimensions. It's just the question didn't happen to answer or ask that one. How are we doing so far? Keep in mind, last year this took us 4 classes with quadratics. Last one we're going to do on dimensions. Again, just read to read, then read to highlight. It's my grandfather used to say all the time. What would you like to highlight? Definitely the dimensions are going to be important. Two more words I would highlight. Carton, which again, think like a mathematician, not anything else. We're not talking like a carton of milk where it's got that funny pointy thing on the top. To a mathematician, what's a carton? It's a box. Okay, if they want to do some fancy shape, they'll give you a diagram or they'll tell you that a carton is just a box. Do we care it's sugar? Not in the mathematician world. We could care less what's inside. That's not for us to worry about. That's engineers and product people to worry about. There's still one other word I would highlight. Capacity. Capacity is a fancy science word for what? Volume. So you might want to write that in brackets. Capacity, volume means the exact same thing. Capacity means how much something can hold, so does volume. Okay, so how is this one different than 1 and 2? We got to add something. We're given all 3 dimensions, so none of them have x in them like they did in the last 2 examples. Just hang on. What else is different? Yeah, do we know what x is? Have they defined x for us? So the very first thing we're going to have to do is define x, because in question 1 they told us x was? Which one specifically? Width. So it was defined in the question. In number 2 they told us a dimension was x. Here they haven't mentioned x. So if they don't mention x, the first thing we have to do is figure out what is x going to be? Well, what are we trying to find? I don't think we're trying to find volume. We'll need it to answer this, but it's not what the question specifically asked for. New dimensions, and how are we going to find the new dimensions from the old dimensions, or what are we doing to each dimension? Adding some kind of amount. Well, what do we call it when we don't know something? So this is the amount that we adding. Oh no, I'm writing it down because that's what he said. That's awesome. Feel a little like I'm a homeboy now. Totally off topic, but I'm born Christmas Eve, as most of you know, and it came out a few years ago to a grade 9 class. I was born Christmas Eve, and this kid was like, So, like Jesus is your homeboy? That's right. Jesus is my homeboy. We're like this, Jesus and I. Homeboy. Yep. Which I'm like, his birthday's Christmas, but I didn't get into it. He was not a bright light bulb in the amount that we adding to each dimension. Now just note, it's important for you guys that we're adding the same amount to each dimension. If we were adding different amounts, you don't have the math yet to solve that. So the fact is we're adding the same to all three is the reason we can do that. Okay, starting with the same formula we've been using all the time. Volume is length times width times height. So the length was 13, or maybe the width, the height. Again, we don't care. What are we adding to it? X. So the first dimension is going to be 13 plus x. Again, 13 plus x, which tells you what about one side of this carton of sugar? It's square. Ooh. Ah. And the last dimension was 25. It's now 25 plus x. Okay, what about the left-hand side? So what are we doing to the volume? We want to add 350 to it, but what's the original volume? Okay, so original volume has to be 13 times 13 plus times 25. With the original? Okay, can someone just confirm that? Okay, so that means over here we want to take our 4225 and we want to add 350. That's the way these questions will always work when you're increasing the dimension. You'll always have old volume plus what you're adding, and then the 3 dimensions plus x. What's step 2? Any of these questions, what did we do always in step 2? We graphed it. Is this going to be a y1, y2, or just y1 like last example? y1, y2, because we have 2 different sides. Now, we could put the calculator with the adding, or we could just add it ourselves, whatever makes more sense. Let's just add it ourselves. Or maybe not. Offer a 4575. Okay, then 13 minus x. Plus x, thank you. Now, if I was feeling particularly lazy and I didn't want to type that all over again, how could I type it so that I don't have to just square it? Okay, you don't have to. You can type it again if you want to. And the last one is? Okay, let's go right to window and talk about the values. So x, don't forget, is our dimensions. Y is the volume. So what's the minimum dimension I can have? Dimension, smallest dimension possible. Has to be 0, can't have a negative dimension. What's the highest possible? Well, I know it's at least 25 plus something something, so give me an appropriate value. 100. Okay, let's go down to our volume. Smallest possible volume, 0. Well, we need to see at least how much? We need at least our 4575, so 5,000. Okay, let's graph it, see if we can see the intersection. Okay, so if you get to this and you can't see it, what does that tell you? So you either need to change the window, or sometimes you just want to check your y equals, make sure they're both black, because sometimes you can turn one off. That's not the case in this situation, but check that they both have the equal sign black. Okay, so we have them both turned on, so what do we need to change here? What could we not see? Yeah, obviously our x max was either too big or too small. Okay, 500. You have to remember it's a dimension. So are you going to times 5,000 times 5,000 times 5,000 and have a volume that's less than 5,000? Okay, so let's use a little bit of logic here. 1. Ooh, that was the... You got to remember the smallest side of the sugar carton was what length? And he needs to increase the volume a little bit. Is he going to add 5,000 centimeters to the length? Probably not. He's probably adding tiny amounts to increase the volume just a little bit. Yay! There it is. Why could we not see it before? Because we were zoomed out so far we couldn't actually see what was happening at 1. So if you try bigger and it doesn't work, the lesson is try smaller. Now what? Do we want the x or do we want the y? How do we know? The y volume is the volume, and we already have the volume. Can I go 0.4 if we round to 1 decimal, please? And we're done, because that's what the question wanted. It said solve for x. No, what did the question want? Okay. It was 13, but we added. And what units? Second dimension was 13, but we added 0.4. And the last dimension will be? Again, if we're taking a pretty large volume and just adding a little bit to it, it probably means this is going to be a pretty small answer. Because to affect the volume, if we add more than that, it's going to jack it up even more. So typically, if this is small, this is going to be pretty small. How are we doing? Kate, let's leave dimension, and we'll do the second kind, which is age. In your world. Reach ridiculous numbers like that.